Is hearing better in background noise even possible? Maybe, maybe not. Hi guys, Rachael Cook, Doctor of Audiology at Applied Hearing Solutions in Phoenix, Arizona. And in today's video, I'm going to be talking about hearing aid advancements and whether or not hearing aids can get even better in background noise. Coming up. Hearing aids have improved significantly over the past several years. In fact, in 1989, hearing aids only had a 58% satisfaction rating. This is pretty measly when you compare this to satisfaction ratings obtained in 2022 that came in at a whopping 83%. And while just about everything, including technology, improves over time, there are just about two things that we can thank for this improvement in satisfaction. These are new and improved hearing aid fitting and programming techniques and hearing aid feature enhancements. And that's exactly what we're going to be talking about today, especially as it relates to hearing well in background noise. But before we do that, go ahead and give this video a thumbs up to bring videos like these to a wider audience. And while you're at it, make sure you go ahead and hit that subscribe button with notification bell so that you never miss any one of our newly released videos. And a huge shout out to Starkey for sponsoring today's video, but more on them in just a little bit. Now, let's start with improvements to fitting and programming techniques. If you can believe it, hearing aids used to be programmed via small circular knobs that were turned using tiny screwdrivers. These knobs controlled very few variables. They mostly gave your provider the ability to increase or decrease the high pitches and turn volume up or down overall. This analog sound was incredibly limited when it came to adjustments. This means that it could be difficult to get the sound just right for each user. These days, hearing aids are digitally programmable using computer software interfaces. These allow for adjusting nearly any variable that you could think of. This includes precision programming at numerous pitches, as well as adjusting the volume level for incoming soft, average, and loud level sounds. And this is just the tip of the iceberg, as there are dozens, if not hundreds, of individual programming settings and features to get the sound of your hearing aid just right. When fitting hearing aids, we also saw a rise in the use of real ear measurement. Real ear measurement was actually invented in the early 1980s, but adoption by providers has increased drastically over time. This was especially true after the technology became more widely available and after more hearing aid users became aware of this technology once Dr. Cliff started talking about it on YouTube in 2017. Real ear measurement involves measuring the sound level in your ear canal while your hearing aids are in place. This is completed using small microphone tubes with the goal of evaluating how the hearing aid is performing while it's in your ear, as every ear canal is different. Using this technology, your hearing care provider can verify that your hearing aids are providing the appropriate amount of amplification. They can do this in each ear and at several different volume levels to ensure that you're not getting too much or too little exactly where you need it. This is critical when it comes to your ability to understand speech, especially in a background noise setting. Now, when it comes to hearing aid improvements, we have several, but they all boil down to improvements in digital signal processing. Digital signal processing essentially allows providers to take incoming sounds and manipulate them any way that they see fit. This allowed for major advancements in hearing aid technology, including noise reduction. Using sound sampling, hearing aids are able to identify steady noises that do not fall into typical speech ranges and remove them from the incoming signal. Some examples of this would be reducing the sound of a soft fan or refrigerator running, or a loud vacuum or blender running. Another hearing aid improvement was feedback reduction. Feedback is a whistling or squealing sound that's caused when sound leaks out of your ear canals and gets picked back up by the microphone on your hearing aids. In the past, this was nearly impossible to avoid without plugging up the ear canals entirely. But this caused a lot of trouble with sound quality, especially for individuals with mild or moderate hearing loss or that just had high-pitch hearing loss. Again, using digital signal processing, hearing aids can complete a self-calibration measure. A feedback test can identify the exact risk zones for feedback production so that the hearing aid never meets or exceeds these limits. Directional microphones were another added benefit to hearing aid technology, especially when it came to hearing better in background noise. Your hearing aids can identify timing differences between multiple microphones and use this information to give more emphasis to speech and sounds coming from from the front. This helps to reduce bothersome noise coming from the sides or behind you and gives priority to the person speaking directly across from you. Another critical hearing aid improvement was the expansion of assistive listening devices. In challenging and complex listening situations, assistive listening devices can pick up desired speech much closer to the source and stream that speech right into your hearing aids wirelessly. This not only shortens the distance between yourself and the person you want to hear, preserving the volume of their voice, but it also reduces the amount of distortion their speech can get from surrounding noises on its travels from their mouth to your hearing aids. Now, some people just don't want to use an assistive listening device and they want their hearing aids to do it all for them. And even with all of these incredible technological advancements over time, the number one complaint from hearing aid users is still hearing speech in background noise. Fortunately, this is all about to change thanks to the technological advancement called a deep neural network that harnesses the power of artificial intelligence. Just like the one that Starkey, today's video sponsor, is using inside of their new Edge AI hearing aid. A deep neural network is essentially an artificial human brain that has the ability to learn based on the information that you give it. In the case of Starkey's deep neural network, it was trained on millions of sound samples in order to identify the unique differences between speech and background noise better than a man-made algorithm. Unlike other hearing aids that use a DNN, Starkey has integrated their DNN into their new G2 neuroprocessor chip. This allows the Starkey Edge AI hearing aid to achieve between a 10 and 13 decibel signal-to-noise ratio improvement without sacrificing battery life. When it comes to hearing in background noise, the higher the SNR improvement, the better you perform. Without using this new DNN, prior hearing aid technology could only obtain somewhere between a 5 and 6 decibel SNR improvement. But just a 1 decibel increase in signal-to-noise ratio can result in a 10% improvement in being able to understand speech in background noise. This means there's about a 50 to 80% improvement with these new hearing aids when compared to hearing aids without a DNN. But don't just take my word for it. Take a listen here for yourself.
Range anxiety, our goal at Starkey was to remove the fear from hearing aid users that they'll miss out on one of life's most important moments due to running out of battery life in their hearing aids.
Interestingly enough, this is actually Starkey's 7th generation of AI-enabled products and is up to 9 times faster than competing products. But even when stacked up against their own previous Genesis AI lineup, the new Starkey Edge AI is designed to provide nearly 100 times the processing power. What's even more incredible is that they were able to package this DNN into such a compact processing chip. And this allows you to benefit from this technology in even the smallest model of their new product lineup. And because they integrated their DNN into their new G2 neuroprocessor chip, the battery drain that you typically see with artificial intelligence-driven devices isn't a factor. In fact, their products have some of the longest battery lives in the industry, ranging from 33 to 51 hours of battery on a single charge. So to answer our initial question, is hearing better in background noise even possible? I think we can confidently say the answer is yes, especially as this is just the tip of the iceberg when it comes to artificial intelligence and its use in hearing aid technology. But if you have hearing aids and are still struggling in background noise, there are 2 possibilities that you need to consider. One is that your provider didn't program your hearing aids using real ear measurement. Not only does verifying your prescriptive targets using real ear measurement ensure that you can hear your very best in quiet, but it also ensures that you can hear your very best in background noise. Or 2, your hearing aid technology needs an upgrade to something with a DNN, because clearly we've hit a major milestone thanks to the advancements from artificial intelligence. Thanks to new and improved hearing aid features and programming techniques, we already saw a major jump in hearing aid satisfaction go from 58% to 83%. And now, thanks to artificial intelligence, the desire is definitely to see hearing aid satisfaction rates go from 83% to 100%. I guess the next question we have to ask is pretty similar to our original question. Although it's already the best it's ever been, can we make it even better? And I guess we'll just have to wait and see.